Okay. So we just have one last subtopic for transport in mammals, which is ECG, and then we'll switch to gaseous exchange. So yeah, so ECG is very easy to understand. It's not very difficult. You just need to see this graph, and this is it. Okay, when we go for an ECG is basically a graph which shows how your heart is pumping, and we especially do it for anything, for any diagnostics of cardiac problems. Okay, so ECG is the first thing that needs to be done. So it's basically the graph. It's the graph of voltage against time, and we need to understand what is the meaning of these labelings: P, Q, R, S, T. So you just need to do this, and there's nothing much that else is required for you. Okay, so basically, when we are recording an ECG, electrodes are placed on the skin over opposite sides of the heart, and this is done in order to determine the electrical potentials that were generated by your heart. So electrodes are placed, and then electrical potentials are generated by the heart. These electrical potentials are your atrial systole and ventricle systole, and then your ventricle diastole. Okay, so all of those are detected in form of electrical potentials, and then we record them over certain time. We know that one cardiac cycle is it's of 0.7 seconds, right? So the resulting graph of voltage against time is called an electrocardiogram. So you need to remember that this graph of ECG, it's plotted over voltage against time. So time obviously is your x-axis and voltage is your y-axis. Then you need to understand, because this question usually comes for your MCQ part, and you need to understand what is the meaning of P wave. So you see this slight elevation, which is known as P wave. So the slight elevation on the graph before this entire complex, before the longer complex, you need to understand that your P wave represents the wave of excitation which sweeps over your atrial walls, which means that P is your atrial systole. So whenever your atria or whenever your atriums are going to contract, it will generate a smaller elevation, which is known as P. Then we have the other longer elevation, which is QRS. We call it QRS complex as well. So do not worry if they give you QRS complex. It's the same thing. Because so the QRS waves, they represent the wave of excitation in the ventricle walls. Since the pressure in your ventricles is higher as compared to atrium, the elevation in the graph is quite larger as compared to the elevation in the atrial systole. Okay? So this is exactly why the contraction or the wave of excitation for ventricle systole is much higher. So QRS is the representation of your ventricles being contracted, and then we have this recovery, which is your ventricle diastole, which is not very which does not last for a very long time, but rather it indicates that now your ventricles are in a recovery phase. So right after ventricle contraction, we have ventricular diastole. This is a part of your cardiac cycle in which you see an atrial systole, then ventricle systole, and then you see ventricle diastole. So ventricle diastole represents the recovery of your ventricle wall. Make sense?